Welcome to Ask and Learn.
Okay, so for this question, we're asked to match the differential equation with the graph of its solution. And we're going to do this by seeing what properties of the graph we can deduce from looking at the differential equation. And we're going to do this by noticing that y prime should be the rate of change of whatever is represented by the graph, or if you prefer, the slope of the line tangent to the curve at that point. Okay, so for A, first of all, we notice that y prime is going to be always greater than or equal to 1 because x squared plus y squared is always greater than or equal to 0. So any solution to this differential equation needs to be strictly increasing. That narrows our options down to either 3 or 4. To decide between the two, we notice that x squared plus y squared gets bigger as you move further away from the origin, since both x squared and y squared increase as you move away from the origin. So you would expect that the slope of this graph, or the rate of change, would increase as you get further away from the origin, which leaves us with just 3 as our solution for A. So A gets matched with 3. For B, we now notice that e to the negative x squared plus y squared is always greater than 0, but x changes sign as you flip over the origin. So e to the negative x squared plus y, so the solution to this function should be increasing on one side and decreasing on the other, which leaves us with either 1 or 2. However, 2 cannot be a solution to B, because if we assume y is equal to 0 identically, then y prime in B is not also identically equal to 0, since we're just left with y prime equals x times e to the negative x squared, which is not a constant function. As a result, the solution to B cannot be constant. At least if y is equal to 0, it can't be constant. Or it can't be y equals 0, I mean. So we're left with just 1 as an option for B. Okay. For C, once again, since e to the x squared plus y squared is greater than 0, greater than 0, y prime is going to be greater than 0 everywhere. So we have a strictly increasing function again, leaving us with just 3 or 4 as an option. Since we've already used 3, we can assume this is 4. But if we didn't know that A was 3 already, we could deduce that C was 4 from the fact that the denominator of this fraction increases as you move away from the origin. So y prime gets smaller and smaller as you move further and further away from the origin. So you would expect the rate of change to decrease, which is exactly what happens in 4. Now for D, our only option left is 2. However, you can also see that if you plug in y equals 0 into the differential equation for D, you get y prime equals sine of 0 times cosine of 0. So y prime is equal to 0. So the constant function is a solution to, the constant function y equals 0 is a solution to D.